and gentlemen, boys and girls, cats and dogs. Today, we're going to take a brief recap into what learning in memory is, and then we'll go dive into our memorable moments lesson of the day. So, talking about learning in memory, learning, again, is the process of how we acquire or get new information. So this can be through copying other people. It could also be by practicing or repeating a new skill. And it could be through a number of different ways where we try to get new information. Memory is the process of saving that new information that we learned and recalling it when we need it. So, this could be, for example, memory that lasts for a short while, short-term memory. It could be long-term memory. It could also be different kinds or contents of memory. So it could be facts and events. It could be steps of a process, etc. And so there are different ways of thinking of learning in general, memory in general, and this lesson that we'll be talking about today will help dive deeper into the process of memory.
Okay, so now we're going to move on to a more in-depth look at learning and memory. Specifically today, we will be trying to answer 3 questions. 1. Where are memories stored on the brain? 2. How or by what processes are memories stored? And 3. How do we learn this information about the brain? So what tools and methods do scientists use to draw these conclusions? So let's take a look at that first question. Where are memories stored in the brain? Well, what do you think? Can we just point to one specific location in the brain and say, right here, that's where all that information goes? Or maybe this location is where all of the events are stored, the things that have happened throughout your lifetime. But way over here, that's where all the facts are stored. Can we say that? Well, the answer is no, we can't. There's not one specific location in your brain where all of your memories are stored. So based on this, what do we know? There are still a couple of important areas and distinctions when it comes to memory storage. First of all, your cerebellum is an area toward the back of your brain that is very important when it comes to motor function and control. And we know that this is where your procedural memory is stored. This means your memories of how to do things, which makes sense because your cerebellum is so important in actually carrying out these movements and actions. We also know that a lot of your other memories, specifically declarative memories, meaning your factual knowledge, is stored in the cerebrum. This is a large area toward the front of your brain that is important for higher level functioning such as logical reasoning and decision making. Once again, this kind of makes sense because you need to call to mind a lot of declarative memory when doing something like weighing pros and cons in order to make a decision. So now we're going to move on to the second question and begin to examine the process of memory storage. When considering this process, it's helpful to think of your brain like a filter. You start off with a lot of information and then gradually pare it down to only the most important material. So we start with sensory memory, which includes absolutely all of the information that your body and senses are collecting. This goes beyond just your 5 senses to neural impulses that you are receiving about your own muscle movements or balance. So for an instant, only about 1/10 of a second, all of this information is stored in your brain, which means that technically we have photographic memory. But this is way too much data for your brain to handle, and most of it is unimportant, so we begin to filter. When converting from sensory memory to short-term memory, Evolutionary processes are very important. Your brain asks, what is important? What are the big threats? What is going to determine how I act in the next couple minutes? So you tend to remember large things, threatening things, rather than small details. You've walked through your living room 1,000 times, right? But can you remember the exact location of the pictures on the walls, of the curtains and the patterns? Probably not, because that information is largely unimportant to your decisions in your life. So this short-term memory lasts seconds to minutes, but you're still constantly forming short-term memories, and this is a lot of information. So your brain filters again, creating long-term memories. These can last from hours to years to your entire lifetime. And once again, your brain asks, what is most important? That's why the creation of long-term memories is solidified by trauma, so very important and influential experiences and repetition, because you tend to repeat information that is really important. So now we know the process by which your brain sifts through information and filters out only the most important stuff, converting from sensory to short-term to long-term memory. But the next question is, where? Where do these processes happen? Scientists have found that this little location in your brain, called the hippocampus, plays a huge role in converting memories from short-term to long-term. You have two hippocampi. They're located in the temporal lobes, which are the side lobes of your frontal cortex, which we talked about earlier. And these hippocampi are especially important for storing declarative memory. Do you remember that? Declarative memory is facts of people, places, things that's stored in your frontal cortex. And another interesting thing that scientists have discovered is that you only need one hippocampus in order to continue with memory storage. But next we're going to go into how we know this stuff. So how do we learn about neuroscience and how the brain functions? Well, this is primarily through brain malfunctions. Specifically, two ways: localized brain damage and diseases. So for the stuff that we're studying, the conversion of short-term to long-term memory, we're going to look at the case of HM, which had localized brain damage, and Alzheimer's disease. HM was a patient with severe epilepsy, and in an attempt to cure his epilepsy, he underwent drastic brain surgery. But at the time, we didn't know as much about the brain, so surgeons removed large areas of his brain, including both hippocampi. After the surgery, he had his previous memories, but he could no longer form new memories of people, events, or facts, which, as I mentioned before, is declarative memory, that the hippocampus is so important in forming. However, HM was still able to learn new motor skills. So this case really helped show that declarative and procedural memories were stored separately. And specifically, it showed that the hippocampus was an area very important in forming the new memories, but not necessarily storing them. Alzheimer's disease was also an important factor in helping neuroscientists learn about memory storage. It's a degenerative disease that gets worse over time, and it causes overall brain cell destruction, but specifically an early target is the hippocampus. As you can see in the diagrams, on the left is a healthy brain with the hippocampi circled, and on the right you can see that this area has practically been destroyed, causing severe memory loss and difficulty forming new memories. So this data reinforces the importance of the hippocampus in declarative memory formation. And this is very important because scientists can't just draw conclusions from one data, like the case of HM. They need more findings to back up their conclusions. Okay, so that about sums up where memory is stored, how memory is stored, and how we know. This is just a quick check for your learning. On the left is a list of terms that we talked about today, and on the right, a list of definitions. So just pause the video and try to match the term to the definition. It's okay if you don't get them all right, it's a lot of words. And now I'm going to move on to the last slide to give you the answers. Thanks for listening today. Bye guys.